Hello, everyone. I trust you've all had a very excellent lunch because we are in New Orleans, the city of the most fattening lunch of all time, I think. How many agree? Yes? Best, most fattening lunches ever? So this is a talk I'm giving today. The talk is about GitHub flavored Ruby. And what I mean by that is how we craft a system, a methodology around the Ruby code that we write, mainly libraries. And I know this all sounds very fascinating. But first, I want to explain to you why I'm wearing such a fine shirt, because I know you're all wondering. So if you go to shop.github.com right now, I believe, and if not, within the next several minutes, you all will be able to purchase this fine shirt for yourselves. And I know you're wondering, but Tom, why is it pink? The astute amongst you will observe that today is October 1st, marking the beginning of Breast Cancer Awareness Month. And you'll also see from the back of this fine shirt that it is a very stylish homage to what we are at GitHub trying to support, which is research into Breast Cancer Awareness Month. So in light of that, all proceeds from the sale of this shirt will go to benefit the Susan G. Komen Race for the Cure benefit for breast cancer research. Thank you very much. That's all. No, actually. So let me introduce myself. I am Tom Preston-Werner. This is my handle on GitHub, Twitter, everywhere else that you will ever find me on the internet. I, of course, work for and am CTO of GitHub. And I already did that part. Check out this high-res image that I totally just jacked from that page because I didn't have any internet. Little thumbnail. This is the future, people. The future of internet is before you right now. So today's talk is going to be around these 5 technologies. Not really technologies, approaches, methodologies, ways of making things more awesome. So the first, Relentless Modularization. The second, Readme Driven Development. The third, Rake Gem. The fourth, TomDoc. And the fifth, Semantic Versioning. These together form the basis of a lot of what we do at GitHub when it comes to deciding how to code, what to code, and how to let other people know what we're coding. So let's talk about the first, Relentless Modularization. Perhaps you've seen some research online. There is plenty. This is a simple diagram of 2 projects. The one in blue is very small. The one in large, as you can see by its name, is very big. Now, when we approach code bases, when we start coding, projects start out small, and they approach big shittiness over time. So how many of you have a small project and have noticed that these projects are a pleasure to use? They're a pleasure to write. They're a pleasure to change. They're a pleasure to integrate with. They're a pleasure in every kind of way. When you work on them, they make you smile. They make you say, beignet. Beignet. Perhaps I'll take myself down to Cafe du Monde and beignet myself a pat on the back with 4 pounds of powdered sugar. So this is what we feel when we work on small code bases. When we work on larger code bases, we get the Sparta scream inside us, and we want to kick people into giant bottomless pits. And why is that? It's because these large systems, these systems that grow over time, large monolithic systems, big Rails apps, big things that we build for the enterprise. For some reason, the enterprise always has a lot of these. They end up this way. And they end up this way because of the spaghetti codiness. The spaghetti codiness, or the tangled slinkiness of these large systems, leads us to have a really hard time changing them. It's what's called tight coupling. Tight coupling is where all of your systems belong to the same big system, huge system. When you want to go change one thing, you break 1,000 others. And that's because the code is all intermingled. You don't know where one starts and the other begins, like this really fucked up Slinky. So you're asking, how do I modularize? How do I decide what to modularize or when to modularize something? Like, when does something become so big that something else needs to be extracted out of it? As you're coding, you should constantly ask yourself this. And every line of code that you write, you should be wondering, should this be modularized? And I say that the answer to this is everything should be modularized. All right? I yell that because 2 weeks from now, you're going to remember this talk and be like, hey, what did he say about modularization? When should I? Oh, right, everything. But time heals all. And so over time, it will become less. And you'd be like, did he say modularize most things? No, you'll remember everything. And that is why the baby is yelling at you, to burn it into your minds. This slide left intentionally blank. So at GitHub, let me tell you about our modularization process. It goes a little bit something like this. We sat down in the beginning, we said, let's build GitHub. And so we built GitHub.com. And then we said, this thing is becoming big. So what do? Modularize. So it started with Grit, which is a library for communicating from Ruby to Git repositories on disk. And then we said, we need to be able to scale this thing out. So we built the smoke system, which allows the front ends to talk to the back ends. And then we built BERT RPC, which is the RPC mechanism by which those things communicate. Those, of course, go through proxy machine, which establishes the connection between the front ends and the back ends. That's routed by Chimney because Grit is smoke in the cloud, obviously, which is routed by Chimney, right? Yeah, no, see, it makes sense to me. Behind that process is Ernie, which is a BERT RPC server, which runs the rest of Grit on the file server side. When anything goes wrong, that's handled by failbot. Jerv is when you SSH into a system. Rescue is for handling jobs. RockQ is for putting jobs into Rescue. Jekyll is for making pages that are awesome. Node load is for handling downloads when you download things. Albino is for handling pigments and giving you nice colored things. Markup is for turning all kinds of different formats into something that you can look at on a page. Camo is for proxying non-SSL images into pages that are SSL and otherwise would cause that little stupid-ass lock thing in your, yeah. Golem is for handling the wikis. Heaven is so that we can deploy shit. Stratocaster handles all the events. Amen is for graphing. Haystack is reported to by Failbot, our exception logger. Hubot gives us a good time. Services are what you guys write to integrate with services. It's open source. Help.github.com is a separate modularized system so that you can learn how all of this crazy crap works. And now, what is the takeaway from this? How do you look at this and make any sense of it? Sure, you say, GitHub, congratulations, you're really bad at naming things. But I think the lesson comes from this guy, Mr. Rogers, because Mr. Rogers was, if nothing else, extremely talented at make-believe. And that's the point of modularization that is interesting. The interesting thing about how we approach modularization at GitHub is to say, this piece of code has become interesting enough on its own such that it could become an open source library. So anytime we sense that any one of those components that we're working on is becoming interesting enough to become an open source project, then we will split it out and start treating it as an open source project. Even if we have no intention of open sourcing that library, we will build it as if it was an open source project. Because that is how you decouple systems. That is how you think in generalized terms so that you don't build in all kinds of configuration variables and other little things that you do within your company that make sense to you, but that make it hard to reuse your own technology in other places within your company. So always be thinking open source when you're modularizing things. It really prevents you from getting into that slinky situation because now all your pieces are generalized and separated. You can take that one step further and do what we really try to do, which is actually open source things. And here's what you tell your boss when he comes to you and you're trying to open source something. Say, why would we open source this? How is this useful? Why would we do this? What we do is open source anything that is not a direct business secret type thing. So for us, it's github.com. That is the main, that's the goodies right there. GitHub.com is the goodies. Everything else, all the infrastructure, all the other little open source tools that we build, those we open because they don't give us any strategic value. It's infrastructure. It's what we're building upon, just like we build upon Linux and Nginx and Rails and all these other things, we want to give back to the community. And we can do that safely because we know that our competitors can take all of these things that we open source and use them, but they can't compete with us on the same level because they don't have that one thing that is the goodie, which is GitHub.com, the Rails app. So make that argument. It's not a specific core business value item. Any kind of server technology, any kind of infrastructure, tools for analyzing data, all that stuff is really great to open source because it gives you a lot of benefit in the open source community as well and helps you hire. All of these things play together. So we try to open source as much as we can, and I think everyone here and every company here should be doing the same thing. All right. Readme Driven Development. How many people have heard of Readme Driven Development before? Okay, wow, that's amazing. So I'll just skip this section. No, instead, I'm going to show you an awesome picture that I found on the internet. Ta-da! Check it out. There's like this big castle thing. This is like some Game of Thrones shit right here. This is like a huge waterfall. You know, like Niagara Falls times a billion. I'm not just showing you this picture because I like describing it. I'm showing it to you because, of course, it has a waterfall in it. How many of you despise the waterfall process? Deep down with waterfall. And here's why we despise it. We despise it because I have a, holy crap. See the fire. This is the fire of evil. It makes me trip on metal things. You can actually set a keynote transition to be as long as you want. This is the waterfall process. It starts at requirements, design, implementation. It's called waterfall because each step must be completed before the next one may be begun. And we hate it because it locks you into making decisions and then never changing them before. The funny thing about waterfall design is that it was created sort of by chance or mishap by a guy named Winston Royce in 1970. He wrote a book that explained this system and then went on to say that you should never use this system. He was using it as a counterexample. Now, some people didn't read that far in the book, and they said, hey, that's a fine way to design some stuff. And they used it, and they were like, waterfall is awesome. And then the government wrote specifications and baked it into their process. And then we were all doomed since then with overly big, overly specified, under awesome government types of things. And that is waterfall, the big evil, the thing that we as Rails developers and Ruby developers hate the most in the world. So, to remedy that situation, we invented cowboy coding. The thing about cowboy coding, while it's extremely enjoyable as being a cowboy is that there's not really any rules to be followed there, right? We're all just on our own, typing away, having a good time. Oh, wait, you want me to specify this first? No, I'm a cowboy, I got my lasso, I'm going to lasso me some code. That doesn't make sense. Okay, yes, so we went too far in the other direction, though. When you don't have any specification, when you don't have anything to go off of, then you end up with code that is just a mess. You don't know what you're doing, you're re-implementing things, you're wiping out whole chunks of code and redoing it because you have to go back to the customer because you wrote it wrong in the first place, and you never gathered any specifications at all. And while that's fun, it's not very productive. And as I like to say, a perfect implementation of the wrong specification is useless. And that's what happens in either the waterfall case or the cowboy coding case. It's the wrong implementation. And even if that code is the greatest, cleanest, most amazing code that you've ever written, at the end of the day, if it doesn't solve the problem that you intended to solve, then it's useless. So is there a middle ground? There must be some middle ground that we can do that gives us the best of both worlds. Some specification, but not too much specification. And of course, you already know the answer to this because it was in the title of this part of the talk, is that you write your README first. And that's really as easy as it is. You open up Vim or whatever crazy crap you're using, and you start writing. You start writing the README. Go find a README that you like. Go find a README that speaks to you, that is like, wow, this is a great README. It tells me everything I need to know to get started with this project. Go find one of those And then for your next project, that next project that you've decided to modularize, start writing the README. And write it in exactly the same way that you see it, fully formed, as if it was a fully formed project. So in your mind, think ahead to when some user is going to be interacting with the software and trying to figure out what it does. At that point, you are thinking far enough ahead that you can make decisions, good decisions, about how the fully formed project should be. If you start coding right away, you're going to discover as you're writing code that you have to go back and change things all the time because that abstraction was wrong and that API method that you decided would be great doesn't work at all, or these methods are wrong. If you write the README and explain in code, before you even write any code, just write it from an end user's perspective, then you'll have something that will be delightful to use because you imagined it being used before you even wrote it. So this gets a little weird once you have an empty project that is just a README and someone goes to it and they're like, this project is amazing. Ah, crap. So to solve that problem, what I've started doing is writing the README, getting it to a certain point that is kind of awesome, and then renaming it to spec.whatever format you're going to use. This now offers you a place that is what the README is going to look like eventually, hopefully. And as you begin writing and implementing parts of that README, you move those chunks of the README over from the spec into the proper README. And that way, when someone comes to your project that is half implemented, they see only the things in the README, the real README, that are implemented, and they can start using it in its beta form without being really confused about what is and is not available. If you would like to learn more about this, you can go to the Googles and just type in Readme Driven Development. You'll find my blog post probably as the first result. Otherwise, go down until you see tom.prestonwerner.com/some crap. And you can read a big thing that I wrote about it, explaining all of this stuff, why I think it's awesome, how I do it, and why it's the right decision. So that is Readme Driven Development. And it's worked really well for me. And a lot of people that I've talked to say it's working for them. So give it a shot. If it doesn't work out, whatever. But I think you'll like it. The next step along this fantastic journey is Rake Gem. And Rake Gem, of course, is a plugin I wrote for Minecraft that allows you to get rubies out of grass with a rake. So the way that... No, I'm just kidding. It's not that at all. Rake Gem, although that would be pretty rad, right? You spend like 1 million hours down in those dungeons. You guys find yourself when you're playing Minecraft ever, you're down in like the dungeons, and it's like 3 in the morning, and you're just like, oh my god, diamonds. There's going to be diamonds in here somewhere. There's got to be a diamond. Why do we do that? What is it about us that makes us just mine for hours? For what? Oh god, I had to give up Minecraft. It was like totally... Don't get involved with Minecraft if you haven't. It's like the end of your life. Don't do it. Don't do it. Stay away. Okay, so Rake Gem, rake-based gem builder. Many of you probably use Jeweler or Ho or some of the bundler stuff or whatever to handle how you produce gems. So you're sitting in your project, in your gem that you've decided to modularize and open source, of course, and start with your README-driven development approach. You've got some code, and you want to share that with someone else via the amazing Ruby Gems ecosystem. So how do you do that? You want to be able to get in there and use some rake tasks, and that's what those systems are for. I've found some problems in the past with how those things mesh with my idea of producing gems and shipping them and tagging them and all the things that I want to do. And the number one problem that I had with them is that I had to require them. And when you had C extensions that you needed to build and they wanted you to put the version number in some crazy place, all of this stuff was really weird to me. And I said, this stuff is not so complicated that it needs a totally external system. And so I wrote Rake Gem, which is a collection of files that are really just templates. And there are no dependencies. These are just templates that you copy into your own library when you begin it, and you base your future rake file and gem spec off of these 2 files that you will copy. So really what it is a hand-rolled gem spec and a handful of rake tasks that allow you to do the normal things you want to do, things like deploying or rolling a gem, building the gem, pushing it up to GemCutter, running the tests, creating the RDoc, etc. And so you get all of this with Rake Gem without having to require anything. So let me run you through first kind of what it looks like so you have an idea of it. This is what the gem spec looks like if you go to the Rake Gem library on my GitHub and look at it. This is the gem spec. So it has a lot of exposition that explains all of the different things in a gem spec and what they do. Kind of holds your hand through that process. You read the comments, and then you fill in the values programmatically. You're just crafting a nice gem spec, the way that gem specs were meant to be. And gem specs are really a pretty great approach to this. They're very simple. It's a very simple specification language. And it's exactly what I want to do in order to specify those things about my gem that are necessary to do this process. So let's use that. It already exists, and it's great. So you go through here, and you put in your summary and your description and your authors, email, et cetera, all the way down. And that will now be the basis of your gem. Tells it how to create a gem out of it. Along with that, you get a rake file template that you copy into your project, and it looks like this. The top of it is mostly just yanking names out of things, like finding out what the name of the thing is via the file name of the gem spec, little things like that, like how to get the version, like where the version is. And Rake Gem says, I think you're going to put your version as a constant in your top level thing.rb. If your gem is called thing, then you got the thing.rb in the lib directory, et cetera. That's where it finds it. This is all explained in the README for this project. So you get this template. And because of that, you get all of these rake tasks that come along for the ride. These are what is contained in Rake Gem, all the things that you're used to doing with your other packaging systems. But the really nice thing about this, the thing and the reason that I wrote it, is that Rake Gem is infinitely customizable. More customizable than anything you could possibly imagine because it's just code in your repository. Customizing it is really going into your rake file or your gem spec and changing something. There's a whole section of the rake file that says, put your customized tasks here. It's designed for that. Here's a little bit lower in that rake file. You see some tasks related to releasing. So here's the release task on the top. And the way that I release is I want to make sure I'm on the master branch, so we'll test for that. I'm using Git, maybe you're using something different. That's fine. Guess what? Go in there and change that command to be whatever you're running. And then I commit it, and I allow empty ones in case I want to. I have a pre-built message that's going to happen. I tag it with v something because I like v something. But if you don't like v something for your tag names of your releases, then remove the v or change it to like a q. I don't care. Doesn't matter. Because it's just code in your thing, right? You can just change it however you want. Yes, you get it. Okay. So this is where you go to find this project. Read the README. It'll describe all this stuff. And give it a shot on your next project. I think you really like it. It's really changed the way that I approach this because now instead of worrying about digging up the documentation for one of these other projects, how to override something, in Ho you used to have to explicitly remove it from the dependency chain because it would like include itself because there were no developer dependencies, but now we have that, so you don't have to do that anymore. There's just shenanigans that you're going to want to do. This allows you to do it. So that is Rake Gem. So next up is TomDoc. TomDoc is a project that I've essentially been developing for about 5 years. At first, it was really just a modification of simple RDoc format. I looked at RDoc and I said, hey, this is how people document their Ruby code. I would like to also document my Ruby code, so I will use this system. But RDoc doesn't really tell you much about how you should document your things or what the approach is. Like, should you describe things? Like, how do I document variables or parameters and things like that, and specify types? So this is where TomDoc came from. I started just writing RDoc in such a way that made sense to my mind. And it didn't really, eventually it drifted apart from standard RDoc type of formatting and went into something else. And before I talk about specifically the formatting of TomDoc, I want to talk about at which level of documentation TomDoc exists. I think there's 4 levels of code documentation. Those are line code. That would be something within a method where you describe a tricky section that's maybe doing some kind of crazy looping or calling out to some external system and doing some weird parsing that you don't understand by just reading the code. You want to know why that thing is happening. You put some line comments in there above each line of code, and then you're fine. Code documentation, that's going to be at the level of methods and classes. So this is where TomDoc is going to stand. This is describing methods as a whole, more of your API. This is where RDoc and Yard and all of them sit. That's code level documentation. Next up that chain is API documentation. That's a little bit similar to code documentation, except that it's aimed at a different audience. The audience of code documentation is developers in the code. The audience of API level documentation are end users who are on the internet looking for documentation on how to use and consume your library. They don't care about the code that's in your library. They only want to know how to use your code in their libraries. So API consumers. And then above that, we have book level documentation, which is long form, very expositional, hand-holding type of documentation like a book on Rails. As I said, TomDoc is code documentation. So why do we want to document code? What's in it for us? Why would we spend the time to do this? These are the questions that I ask myself when I'm writing code. These are the things that I want to know. We've got, well, what does that code do? Like, what even does it do from a high level? What does this method do? Is it part of the public API? Should I feel comfortable using this method in my code and assume that it won't change unless you tell me that? What are the parameters that you expect me to give you? What types are those parameters? In Ruby, we're all duck typed, and so the parameter type that you want to give someone is unknown. You have to dig into the code if there's no documentation to find that out. So just tell me. That's what I want to know. What are the valid options? In Rails, we oftentimes have long chains of very complex option hashes that we can pass down through a whole stack of methods. I want to know every single option that I can provide and what that option does. How do I use the damn thing? Give me an example. I would love to look at an example. That's all I want in my life is an example of how I use this very complex chunk of code. And then, what type of thing does this return? What Ruby type does it return? That would be extremely useful to know, or to know that it doesn't return anything that I should care about. But more important than all of these things is the real reason that I want documentation, and that is so that my future self is protected from my past self. And this is my past self. Check out that shirt. Look, I love ketchup, all right? I'm not ashamed to say that I love ketchup, okay? And neither should you. This is my past self. And the reason that I can still work on the gems and all the open source that I do today is because this guy was looking out for me. He was looking out for future Tom, saying, hey, future Tom, I'm going to document this method for you so that 5 years from now, when you come back and you need to modify this method, you don't have to spend a half an hour reading the code. You can very simply understand that whole chain of thought by just reading these few lines. So that is the real reason that I want documentation. Future protection from past self. So let's look at it. Let's look at TomDoc in detail. What does it look like? So here's a method. It's called exist ? This is in Golem. Golem is totally TomDoc if you want to check it out. That's a good place to do it. And I say, okay, well, what does it do? I have no idea. There's really nothing here. I mean, I can't see the code. I'm sure it's simple, but what does exist? What kind of existence does that mean? Now, once I document this thing, I answer a lot of questions. I can say, what does it do? Well, it checks whether a wiki's Git repo exists on the file system. Oh, okay. It's pretty straightforward. Is it public? Oh, yes, it is, because it says public : in the beginning. What type is returned? Well, it returns a Boolean. True if it exists, false if it does not. So it's starting to answer some of these questions that we really care about. Here's another one. This method is called writePage. Takes 4 parameters. Name, format, data, commit. Those could be anything. If I'm just looking at the code, this is going to take me a while to figure out what each one of those is and what each one of those does. So I write a little bit of documentation. And this honestly doesn't take that long to write. It's pretty quick to write. but it's going to save you zillions of hours in the future. So now I can answer some other questions, such as what parameters are expected? Well, I've got a nice list here, name, format, data, commit. Commit is a bunch of options. It's an option hash. I can go in there and I can see very easily what all of those things are. And then what are the valid options? These questions are now asked by spending about 30 seconds reading that piece of comment. Another one is, how do I use the damn thing? CNAME. That could mean anything. Self.cname, right? Class method called CNAME. Even with just a description, it might be confusing. If I just say, convert a human name into a canonical page name, well, maybe that description could be better. Without an example, you're really confused about what that means if you don't already know what a canonical page name is. So here I show an example, and I say, oh, well, you take a human-readable page name like you're going to see on a wiki page, and you want to convert it into something that you would put inside the URL. And so this says, oh, it looks like it's going to do some changes to make this thing usable on a URL by replacing spaces and maybe other special characters with dashes. So now you know exactly how to call it, exactly what kind of thing is expected, and what you should expect as a result. So the whole specification is up online. This is what it looks like. It's very simple. It's written in a very basic spec format, and it expounds upon all the details about how you should use it. But please remember that TomDoc is not a rigid specification. I mean, when you read it, you'll say, oh, this is a very rigid specification. But more than that, TomDoc is a lifestyle of just documenting stuff and not having to remember or make decisions about what the format of that should be or what it should look like. Just, I want some documentation. These are the ways that I think it looks really great and works really great. But at the end of the day, as long as you're producing documentation, if you get a few little things wrong, if you don't indent correctly or you don't line up this dash or that dash, that doesn't matter. Because all that matters is that you're communicating what the code does to your future self or someone else. And there's one more thing. There's one more thing on this. And that thing is, maybe you know this guy. And originally I was going to use that picture, but that was too weird. So this guy. I'm happy to announce that RDoc 3.10 will natively support TomDoc as a format syntax. So now you no longer have to even worry about, well, how am I going to produce output for this thing? Eric spent the time to integrate TomDoc parsing into RDoc, and it will be available in the next major release. Thank you. I'm super excited about it. I mean, it's huge for me. And Eric is an inspiration to us all, and that's so awesome that he undertook that. So thank you, Eric. Are you here, Eric?
I'm here.
A hand of applause for Eric, please. So this is what the default output is going to look like right now when you do it. It's going to split things into public, internal, and deprecated, just like TomDoc wants. It's going to understand what the parameters are and format them really nicely. You're going to get syntax highlighted examples. It's going to link things properly. It's even going to understand nested option declarations, like the way that TomDoc wants you to do them. All of this is going to be supported in first class. So you no longer have to worry about people looking at you funny when you're TomDocing stuff, and then your RDoc output looks like crap. Very soon, all of that shall be solved. If you want to learn more, tomdoc.org. That's the specification. And lastly, semantic versioning. Semantic versioning is not so much as something that I invented, but a repackaging and naming of something that already existed. There's a lot of power in that. As an aside, if you come across things in your daily life or at work that are complex concepts, sometimes all that's required in order to communicate it, those concepts, those complex things, is to give it a name and give it a lightweight specification. And I've been doing this for a couple of different things. It's really powerful. Just sitting down and saying, how do I talk to someone about this complex concept without having to explain the whole thing? So slap a name on it like semantic versioning, and then write it down in a document and clarify what you're saying, basically a giant definition. And now you can talk about that thing and start finding better ways to do that same thing, or talking about the merits or demerits of that system. So naming things, that's a little bonus takeaway. Naming things, super powerful. So semantic versioning, why is this a useful thing to want to do? There's two things that happen if you don't have a rigid and reliable way to tell people how your versions are changing from time to time. The first one is dependency hell. And dependency, or I'm sorry, the system of getting into trouble is dependency hell. Dependency hell is two things. One of them is version lock. Version lock is when you bind too specifically to a dependency. So if I require for my library Rake, if I want to require that, and I say, I need Rake version 7.3.5. Fine, everything's cool for a while. But what if a bunch of other libraries also declare that they need a specific version of Rake that's slightly different? Now when you need to have both of those systems included in one larger system, the two of them are going to be like, nope, nope, nope. Now which one do you use? Because both of them are saying that they need a very specific release. And so in some package management systems, and this was a big problem for us at PowerSet where I used to work, was that over-specification, this version lock, prevents you from even installing stuff. So that's one side of dependency hell, is over-specifying something so that different dependencies start fighting. You can't even install two things at the same time. The opposite side of that is version promiscuity, where you get sick of version lock and you're like, screw it, I'll just require any of them. Any version of Rake is fine forever. And of course, that's going to lead you to a similar problem, which is anytime anyone upgrades or requires an updated Rake, you're just assuming that all of that's just going to work. Well, that's going to cause problems too. So either way, you've got problems, and you're in dependency hell. So how do you solve this? The first thing that you need to do is declare something like a public API. Whatever that means, whether it's just documentation, whether it's all of the methods that are public. I use TomDoc to specify this, because in TomDoc you can say whether something's public or not. So with the public API in place, now you can start talking about how your project changes over time. And the name semantic versioning means that the version numbers themselves should explain how that thing is changing over time. That's all that you should require. Those numbers should be meaningful. These three numbers should tell you a lot about what happened in that release by just looking at the number. You don't even need to look at the code or anything. These numbers will tell you, if you use semantic versioning, what happened to that gem since the last release. So there's three parts: the major, the minor, and the patch version. The major version is always backwards incompatible. So if I up the major version, that says something in the public API changed in a way that it will no longer work with what you're using right now. So this is generally something like a big change. We don't like to do these very often because it makes people sad. They have to go in, they have to change code, they have to read documentation, all of those things that we as developers really don't want to have to do. The minor version is when it is upped and the major version is not, then that means that that change was backwards compatible. In semantic versioning, you change the minor version, you can upgrade to that, no problem. Good to go. So new functionality, additions to the public API would always be backwards compatible because it's not changing anything. It's not breaking any existing code. Big internal changes you might also want to have be a minor release just to signify that a lot of things changed. But again, it's backwards compatible. As an end user, mainly that's what you want to know. Is it backwards compatible? And this may also contain some bug fixes. You might just roll up a bunch of stuff, maybe an API addition and some bug changes all into the same release that is a minor version bump. And lastly, we have the patch version. The patch version is always backwards compatible as well, because it has to be, and should only contain bug fixes. So if you have some documentation, you say, this method produces this result. But in reality, the code doesn't do that, and you want to release something that fixes that to bring it back in line with what you've specified previously, then that would be considered a bug fix, and that would go as a patch release. In order to take advantage of this, we have something great in Bundler. It's what we call the pessimistic version constraint, or sometimes called the spermy operator. I rather prefer the latter. So the gem command, you say, gem, the name of your gem, use the pessimistic version constraint operator, and then you have a version. And this is a little confusing how this version works. So it's very simple, though. What you have in this version is 2.4. So in this example, this means 2.4 and any version up to but not including 3.0. So as an abstraction, think of it this way. Drop that last number, the 4, increment the last number on the remaining thing up to 3, and then you can go up to but not include that number. So that's how it works. And this is going to keep you really safe because in this case, you want to say, I require at least version 2.4. That has some API methods that I need. Probably maybe from 2.3 to 2.4, some new API method was added that you require. So you have to have 2.4 because you're using functionality in 2.4. And if you can, try to use the lowest number that is actually compatible with your software because that will reduce the amount of vendor lock that you have. So 2.4 all the way up to 3. And now you know that any version 2.4 or higher up to but not including 3 is going to be compatible. According to semantic versioning, it has to be compatible. So now you can very easily upgrade that gem to the new 2.5 version without having any worries. And of course, you should always check this and run your tests and things. But if someone is telling you by the way a version number changes how that works, then you've reduced the amount of effort that it takes to upgrade, and you're ensuring that you don't end up in dependency hell. If you don't do this, then this guy will come after you and suck your blood. I'm really good at accents, in case you couldn't tell. The reason that he's on the screen here is because if you don't use something like semantic versioning, then you may as well just label your versions version 1, version 2, version 3, version 4, because you're not producing any additional information if you don't follow a system like this. Then those 3 numbers, those 3 pieces of that version, are just like digits in a sequence that have no meaning. So you may as well use those pieces of the version number for something useful if they're going to be there at all. You can check that out at semver.org. So in summary, to wrap this up, is your system broken down into small, manageable pieces? If it's not, you might want to consider more relentless modularization. Are you wasting too much time because of too much or too little planning? Are you too waterfall or are you too cowboy? Readme Driven Development might be a nice middle ground. Are you fighting your gem spec or you're working with it? Rake Gem's a way to have infinite customizability without a lot of dependency distractions. Is your documentation aimed at the right audience? I think TomDoc really explains the audience that you should be talking to and reduces the number of decisions you have to make when you're writing that documentation. And does your versioning system help you out or not? Semantic versioning solves a lot of those problems that you get into otherwise. Thank you very much.